Another type of sensor that's available for use with Triggy is this pressure sensor. So it's a little hard to see, but the pressure sensor is scotch taped on top of a mouse button. The mouse is a kind of a typical response device, and the real purpose of this pressure sensor is to detect when a button is pressed and to allow you to measure how quickly your software reacts to that button press. So there are a few conditions that need to be true for this to work. One would be that you need to be using software that can accept response device inputs, but also that it can reflect those response device inputs as digital or TTL outputs. And we're relying on that output as a representation of when it believes that a button was pressed. We'll have our own representation of that based on the pressure sensor. Triggy will produce a TTL output. So in the first instance, we'll check how the press of the button and the pressure signal relates to the TTL out from Triggy. But we'll also observe how when you run an experiment that is measuring responses and outputting those responses, presumably to some other device that's recording both stimulus markers and response markers, how you can use the pressure sensor to know whether or not the timing of those TTL outputs is accurate. So let's just do a first instance test of just the response device with respect to its own TTL output. So I've taped this response or this pressure sensor on top of the mouse, and in the experiment, we're going to use the mouse as the input. But for the first run through, let's just look at the signal that comes from the pressure sensor and its TTL output. So on this side, you'll see that there was a TTL output associated with the pressure signal that came from this pressure sensor. And if I click it again, you'll see that that signal is updated. If I zoom in time by reducing the time base, it's a little easier to see the pressure signal slightly precedes the TTL output. There's a little bit of time required for it to reach the threshold. A few things to understand. Your finger is not completely hard. So when you pressure on a response device, it takes a while for the amount of pressure sensed by the pressure sensor to reach its threshold, partly because your finger is soft, partly because the button has some give to it. So one way to achieve that pressure more quickly is with a more solid object. So I'm using a pencil eraser. And you can see that given the right conditions, the right physical realities, the pressure sensor and the TTL output are perfectly aligned. So inherently in Triggy, the timing is as good as it can possibly get. So you can see that when I press the button with my finger, it takes a little bit of time for the Triggy device to detect that the button has been pressed. It's not the button per se, it's the pressure sensor. The pressure builds over the course of tens of milliseconds. And so it takes a moment for it to reach the threshold. But with a more solid object, that reaction is much more instantaneous. So those are just some realities to be aware of when you are doing an actual experiment with an actual human responder. Now let's look at an example of using the oscilloscope to measure signals coming from an actual experiment. I'm running presentation here, and in presentation you'll hear a few tones. It's just a sort of an oddball task where I'm supposed to respond to some tones and not other tones. For the sake of illustration, I'll respond to all tones, and presentation is coded to send out a trigger when a response is detected. So of course that response is coming via the mouse cable into the software, USB port to the software. And then at the same time, I have the pressure sensor on the button. So I know when the button was actually pressed, and Triggy is recording the analog signal from the pressure sensor, as well as a TTL output associated with the analog pressure sensor. So we'll look at all three of those right here in one window as the experiment goes. So we'll just run a few trials of this. Okay, so if you were paying attention, you would, on this screen, would have noticed that the orange trace or yellow trace is the pressure sensor signal. The red trace, channel 0, is the digital output based on a threshold applied to the orange signal. And then the green signal, this green square wave, is actually coming from the computer. When the experiment is detecting my button press, it's sending out a pulse that says when that was detected. So we can measure the offset time between all those things and determine whether or not the response that's being detected by the computer is coming at the correct time. So let's move our cursor around on this side a little bit so we can see the whole window. We can see the lead up to this response. And let's run through it one more time now that we're oriented. So something that you might notice is that occasionally this green output, the one that's coming from the computer, slightly precedes this red output, which is the digital signal detected by Triggy. And that's because this slightly follows the drop in the pressure signal because of this soft finger effect. So what I'm going to do in the next run through is just press the button with the pencil eraser, and you'll see that invariably the green trace, meaning the one that comes from the computer, will be either aligned with the red one, which is coming from Triggy, or slightly later, but it's jittering around. That's the important thing. And the amount of jitter is likely to be largely a function, at least in this case with the pencil eraser, be a function of the time it takes the computer to recognize what's happening and output a response. So let's just do it one more time here. Okay, so this is kind of a typical delay here. You'll see that takes a little while for the computer to do its job. And software, the quality of the software that you're using will matter to some degree, but to a large degree, this delay of about 20 milliseconds is a function of what the amount of time it takes the computer to do that job. So if you want these event markers in your EEG or eye tracking or other data to be perfectly aligned with the actual pressing of the button, you're much better off either using Triggy with a pressure sensor or the Triggy response device, which will be similarly timed with respect to the actual event and not delayed on the order of 20 milliseconds because of the computer trying to interpret and understand the response before it sends out an event marker.